Hi again. In this part of the Razorback series, we're just going to finish up the upper arm. I'm going to review exactly what I did to complete that. And then I think we're going to move on to some modifications for the pneumatic kickstands. I was looking at the kickstands and I didn't really like how they came out. So we're going to revisit those with some inspiration from amputee runners. So we can look forward to that. So the last time I left you guys with this, we were almost done cleaning up the geometry. And what we can do here is just take a look at what the final geometry looks like. So it's very clean. All of the edges line up as they should. I mean, we can even go in here and continue to refine this to sort of make the polygons flow a little better. And you know, at this point the geometry is pretty clean. It doesn't really matter how they flow. You can see here that there's an extra row of edges. So we had some triangles that were terminating kind of like this. Before this before these edges existed, there was sort of a triangle terminating right here, and so we can fix that by making an adjacent triangle, sort of a brother triangle for him, and then that means that we can just extend this line all the way around down to the other side of the mechanism, and it connects right here where the other triangle was. So that's a nice way of getting rid of the triangles. And you know, for the most part, this part of the arm is done. So we can turn the other part of the arm back on and see where that leaves us. So it does leave us with sort of a requirement right here. This is the only unfinished part. And what I think we should do here is just add another motor unit, but a little bit smaller one, sort of this size, but maybe not even as large. My idea is that the motor for this part of the arm is largely inboard, and the piece that we see sticking out is just a cap. So we can go ahead and do that. I'll just rename this. This should be small arm. And we can simply use our select tool and just use that same technique that I've been using before. So just to recap, there's a few different ways. You can do an extrude inner, followed by another extrude inner. So we've just created a fold. If I were to pull this out, you can see the fold that we've made. And we can just separate this fold a little bit, just so there's a bit of a gap. And then we can extrude just the amount we want. So I mentioned we want this one to be a little bit smaller, one of the smaller caps. And we can then use our loop tool with a bevel, 2 subdivisions, and we create our cap. Now again, these green lines imply that these aren't real polygons, they're n-gons being quadrangulated. And I like to select them and remove the n-gons once I'm done with the modeling operation. That way I know they won't be re-triangulated by Cinema 4D at a future date. And then we can just take our line knife in loop mode. We can just cut around the edge right there, give that nice rounded edge that we like. And there we go. We have our arms nice and smooth and refined. Let's turn off the lines. And we can see here that, you know, what we've got is a pretty good looking robotic arm. You know, there's a few other bits of polish we can add. For instance, we take a cylinder. It's a big one. So let's just bring it into view. I'm just scaling it down. And of course, this will be a 12-sided cylinder, of course. And what I'm thinking is this is going to be sort of an access panel or a cap right down here. We can position it. If we look at the side view, we know that these, we've taken quite a bit of care to make sure that the center point for all of these objects is the same. So we can be pretty confident that if I grab this cylinder and we use the transfer tool, where is it? I have a keyboard shortcut for a lot of these tools, so I have no idea where they really live. I think, here we go, transfer. So my keyboard shortcut is hyphen or subtract. There's no reason for that. I just chose it. So we can transfer it to this point right here. We can change its orientation to X. And if we go back to the side view, we can see it's pretty much spot on. It's perfectly centered. And that's what we want. And I want this to be sort of an access panel right there. So for now, it doesn't need to be anything more than this. But let's embellish it a bit. Let's take the rotation segments up to 20. Even numbers are good for cylinders because it means that if you ever need to do any sort of subdivision or even operations, the even number will usually work in your favor unless you know that you need an odd number. For instance, if you wanted to have five notches on the edge of this cover for like a special sort of a tool to open it, you'd obviously need to use something that's a multiple of 5. So you could do a cylinder that's 10, 15, 20, 25, 30 edges. But in this case, I'm going to go with 20. 20 is also another nice number for a cylinder because it can be divided by factors of 5 or 2, which means that if you needed to use the factor of 5, it'll work. You can get 4 things, or rather 1 every 4 polygons. And so right here we have like this access panel. I just have to scale it so it fits. Now if I wanted it to be larger, there's nothing that says that I'm not allowed to come in here and move things around. So for instance, if I wanted it to be this large and I think this is too close, I can really easily just come in here and say, okay, I'm going to select all the points related to this sort of geometric feature. I can go to the wireframe view just to make sure I've selected all the relevant points and that I haven't selected any points that I didn't want to select. And then we can go back to the side view and just compress this geometry down so that it's closer to this next edge. And we can see here this gives us the gap that we were looking for. So that's pretty good. I like that. Now it does stretch this geometry here a bit, but like I said, I'm willing to live with that. It doesn't really bother me that much. What does bother me, however, though, is we've made this sort of teardrop shape now, and I would really like if we could make it the same shape it was before we started messing with it. So I'm just going to tweak these intermediate ones. By the way, the keyboard shortcuts that I'm using to switch between views, it's F1 through 5. So F5 will toggle your views depending on whichever one your mouse is over. Oh, no. Maybe my F5 has been reconfigured. Either way, F5 is all 4 views. F1 is the camera. F2 is your top. F3 is right. F4 is front. And those are just defaults. Yours might be changed, as some of mine are. And so I'm just going to use the Kayama Slide plugin to try to slide some of these points over. Looks good. So I'm going to drop this cylinder into the hierarchy somewhere where large arm is. So it's now a sibling of the large arm. And what I'm thinking for this is, you know, just to make it look a little bit more like an access panel for now, we can convert it to polygons. We can select all of the faces and optimize them. And then we can, either using an extrude inner or a control scale, I believe will work too. We can just sort of put an angle on this, just like that. Now we can probably come back in here and tweak that further. But for now, I'm just going to reduce the Phong shading to something really low, like 20 degrees. And that'll give us the hard edges that we like here. And so that now looks a lot more like an access panel, and you know, the robotic arm is starting to look like it has a lot of purpose. So now that we've done that, maybe it's time to copy this object over. So if we're going to have one of these access panels right here, we should probably have one up here as well. So let's do that. Just going to do a simple copy. So we can rename this panel, and then we can copy it down to the Oh, it's still going to be on the large arm. I thought it might be in the small arms hierarchy, but it'll still be in the large arms. And we need to transfer it to the small arm. The small arm's pivot point is up here. The large arm's pivot point is down here. So what we need to do is use the transfer tool and transfer it to the small arm, just like that. Now that it's transferred to the correct sort of YZ coordinate, we can actually just bring it out to the correct horizontal position. Use F2, go to my top view, and just position it so it intersects a bit. And now we can just scale it down. And we have another access panel neatly placed on the other end of the arm. I think that works really well. So now our arm system looks a lot more complete. It looks a lot more like a robotic arm. You know, the bright industrial yellow isn't helping anything, so we can get rid of that. The bright yellow just makes it look like a factory worker. But in reality, this is a sci-fi robot killing machine, so it probably won't be painted bright yellow. At this time, I think we can unhide the rest of our stuff and work on the kickstands a little bit. Oh, actually no, let's go back. I was actually playing with this geometry a little bit off camera a couple nights ago, and something occurred to me. If we want this Razorback to be able to fold these arms down as tightly as possible for aerodynamic and, you know, shock factor, the book specifies that the robot has the ability to sort of unfold the arms. It brings some interesting questions up. For instance, how tightly can we fold these arms? We can fold the bottom arm down to that level, because once we get down here, it can't go any further without hitting the main motor hump down here. But when it's like this, it's completely intersecting the main motor. Now this is sort of our fault because we wanted it to come off at a cool looking angle like that. But I think we might be able to save this. What I was experimenting with was adding some geometry at the center here and moving it around. So let's see how that would work. If I take my small arms geometry and at the most simple form, I simply move it so it doesn't intersect that. It works. We can fold it down really nice and tight, but obviously just moving the points up like that doesn't look very good. So instead what we'd do is we'd move the points right around here to where we want the apex of a curve to be. You can just control click on edge mode, and what it does is it converts your selection of points to edges, and that works both ways. You can have a selection of edges and control click on the points, and it converts it to a selection of points. So I select my points and I control click to get my edge loop, excuse me. A ring looks like this, or this, whereas a loop looks like that. And so we can then use our bevel tool. So we can just go down here and say bevel, and I want 0 subdivisions because I don't want it to create any n-gons. And then we can simply just split it out into 2 edges. And then I can move it up like this, and we're sort of starting to get a curve. That looks pretty good. But we're getting some strange stuff right here and right here because of the way the geometry comes out. So before we do that, we can use the knife tool in line mode, and we uncheck visible only and restrict to selection. That way it'll just let us slice right through an object like that. Like I just did this slice, and it basically intersected every single polygon in its path. And that's what we want it to do. We want to do a slice right here, and we want to do another slice right there. So what we've done is just created a little bit of extra geometry that's going to let us move this around with less consequence. So all we need to do is move this up so that it curves, and then we do another bevel operation once it's up there, and it starts to smooth out like that. And we can again come in here and do another cut. Now, I showed this to someone, and they said that it didn't look very good curved. While that may be, this is one of those cases where engineering is going to guide the style. So we want these arms to be able to fold down very far with this little hump maybe. And this is just my way of dealing with it. So while it may not look the most attractive, I think it works, and it actually lets us fold the blades down a little bit too. So I think it actually looks pretty cool. I think it makes it look a little more streamlined and a little more purpose-built. Of course, when we unfold the pivot out here and actually start to unfold the arm, it may look cooler or less cool, less impressive. But either way, I'm sure there's an argument for and against this, but I like it. It adds more of that uncanny sort of, is it a human? Is it an insect? Is it a machine? We know that if the arms were all very straight and rigid, it would be very easy to say, oh yes, that's a robot. But now we're introducing these organic curves into it, and we're starting to think, or at least I'm starting to think, is this simply a machine, or is there some sort of intelligent design or some sort of intelligence behind it? And, well, to find out, you'll need to read the book. But now we have these curved arms instead. And I like how those look, but it started to get me thinking, what if we started to curve it in more than one direction? It may actually look even cooler. So to do that, maybe we want to pull some of these faces here in to make the arm thinner at that point. So what we can do is select our small arm, and we know there's a blade right here. And we can basically select these sets of vertices and move them in. And then we can select the ones on the outside, move them out a little bit just to create that curve. And now we have something that sort of looks like maybe they're just trying to smooth it out, and maybe they're trying to save weight, trying to save space. My opinion of this is that it just looks really cool, so I'm going to leave it. And I'm just going to move that in a little bit so that the curve starts up there and it sort of has like an S curve from both ends. And now we have something that looks a little bit more designed. It looks like there's a little bit less utility and maybe a little bit more style in there. And I like that. So, okay, I think we're done with the arms for now. What I'd like to move on to next are these kickstands. So if we go to the main Razorback object where I have a kickstand pivot, we can probably move this outside of the Razorback machine because a lot of our other components are grouped outside. We have the instruments, we have the arms, and now we have the kickstands. So we have this kickstand pivot, and we know that we can move it to, I believe, 0 degrees was our 0 point, so that's pretty much where it stays always. And now I'm going to open up a little bit of reference material for artificial limbs, because what I was thinking is I'm thinking this looks very medieval. This ram sort of looks like something you might see in a Frankenstein film or like coming down a castle gate. It doesn't look very high tech. It looks like a blunt instrument, and I don't think it belongs on this, which is essentially a sophisticated robot with lots of servos and instrumentation and stuff. But then again, it's a kickstand. I mean, what does a kickstand do? It's just a dull, blunt piece of metal that sort of flips down and supports the bike. In this case, we have a pair of them, so it can be a lot more versatile, but it's still just a kickstand. And it got me thinking, well, it's like a pirate's peg leg at this point. What's the more evolved, modern version of a pirate's peg leg? And let's take a look at that. Okay, so here I've magically opened Google image search, and we're looking at some prosthetic legs for runners. And, you know, this is really interesting because you can kind of see the evolution of prosthetic legs. Granted, these are just for runners. And, you know, this leg has purpose. It's a rigid spring. It's stiff. It has maybe a little bit of grip at the bottom, although Whether our Razorback will need grip at the bottom is arguable. And, you know, this is one of those sort of singularity moments. Not really singularity, but a runner with one of these on is really fast. You know, it's a design that's efficient, and it also looks space-aged. You'd never see, like, a pirate or a medieval amputee running around with one of these. It's just too futuristic, and I like that. I like the fact that it has this future flavor on it. So I think we're actually going to go with one of these types of designs, sort of a rigid spring for each of those kickstands that the Razorback has. So let's take a look at that. Right now we have these large hydraulic rams. I want to keep those, but it would be nice if we could shorten it up and have that rigid spring. So to create the rigid spring, we're probably going to use a sweep NURBS, and we'll take a look at how we do that in a bit, but first let's start taking these apart. We're going to remove the ram, and we're going to edit this housing so that it's a little bit shorter. It looks like it's still got its history. So let's take a look at how this works. Looks like we can just click and drag to reduce its height. Looks good. Now we can create our rigid spring. So sometimes I like to create stuff like this in a new file and then copy it over and scale it into place, because I have a really good idea of what this needs to look like on its own, but in the context here things can get messy. So I've just created a new file. I'm going to go to my right side view. I just hit F3, and we can now use our cubic spline, it's one of my favorites, to create this rigid spring. And so just a really simple shape. Maybe we want to curve the tip up a little bit like that. And let's just take a quick glance back at our reference material. So it looks like it has kind of a kink before it sweeps around. So let's make sure we have a kink in there. And we don't want it to look too soft and graceful, because the rest of the Razorback is anything but soft and graceful. So let's make sure we have a little bit of hard edge in there. I think that looks pretty good. So now that we have this spline, this kickstand pivot, no, I think the base looks too large. Let's just reduce the size of this. I think in general it's too tall as well. And we know that our Razorback's feet sort of sweep backwards, so in reality this stuff here should all be rotated to compensate for that. There we go. So the idea is that the Razorback can deploy these and drag them along the ground, or deploy them really quickly and they'll still have a little bit of give, a little bit of flex in them. And maybe that'll soften the demeanor of the Razorback a little bit and make it seem more fluid. Again, less like a rigid factory worker robot and more like an autonomous machine. Okay, so I'm just tweaking this a little bit more and I think we're good. So the next step is to sweep a rectangle along it. So we're going to use the sweep NURBS and a rectangle. So the way this works is you put the rectangle and the spline in the sweep NURBS. Of course it matters which order you put it in. My rectangle is also huge. And so right now the rectangle is being swept along our spline. If we did it the other way, if we reverse the order, our spline is now being swept along our rectangle, which doesn't look very good. So this is what we want, and we can just convert our rectangle to an editable object so we can scale it and manipulate it a little bit more easily. And so we can just sort of scale it on the X. Maybe a little bit on this Y, make it a little fatter. And there we go, we have the basis for our spring. And we're probably going to want to make sure the proportions look okay. It's sort of a rigid steel or carbon composite spring, so maybe it has a few layers, maybe it's thick, maybe it's thin. Once we have this, we can look at the edges while we adjust the splines, and we can kind of see how that's going to work. What we'll do is reduce the number of subdivisions. So I'm going to leave it as adaptive, but I'm just going to increase the, whoops, I'm adjusting the rectangle. Leave it as adaptive, but I'm just going to increase the number of the angle until we get something that's a lot rougher than what we have, because rougher geometry like this is a lot easier to work with at this early stage of a project. And once we get our wireframe, we can actually come in here and tweak things so that the subdivision is actually more to our liking. So we can still tweak things, and Cinema 4D will dynamically adjust the subdivision to suit. So once we have this object, we can now start to dress it up. So I'm going to press C and convert this to an editable object. It gives us a couple caps on it. We can delete those and recreate them. Easiest way to do that is just to go to polygon mode and then use the fill or close polygon hole object command. So we close that one, close that one. And we can now start to modify this. For instance, I can select this end polygon and scale it on the x-axis to make it look more like the end of the ski or the spring. You can scale these in, coming down to the tip. Make it sort of taper. I believe tapering is the word I'm looking for. And we can just taper it down. Looks good. We can also taper the thickness if we want, but let's not get bothered with that right now. And we can probably also imagine that there's certain sections of it that'll be narrower to provide more spring. I didn't select all the points there. Yeah, so certain points might be narrower to provide more of a spring effect. And certain points up here, we might just get rid of these. I'm not confident that we'd need those. We can recreate that using extrusions. And so now we have an item that's sort of the spring that I was envisioning. We can copy it, and we can just switch to our other project. Another one of the things I love about Cinema 4D is it lets you have multiple projects open in parallel. You don't know what a joy that is until you've used a program that doesn't allow that. So we can scale the spring down a little bit, and maybe let's try that transfer command again. So let's transfer it to the RAM. Looks good. And now we can scale that down. And maybe we want to shift our geometry so that it lines up like that. And then we can sort of think to ourselves, alright, spring probably needs to be a lot smaller than I have it right now. So I remember when we were first creating these rams, we knew that flipping the ram down might be enough to create general stability. But then there may be circumstances where you wanted to extend the ram. And in this case, we can see that because the spring is giving us so much of this flexibility, our ram may actually be able to be a lot shorter than we have it. It may only need to provide a little bit of throw instead of a lot of throw like we have right now. And so this might be what it looks like regularly. And then maybe it extends to about that, which might be enough to lift it off the ground just barely. But the idea of lifting the machine off the ground is a bit less of a priority right now. We just wanted to change the design. We want to change the design of these basically. So now that we've scaled it down globally so much, I definitely feel like it needs to become fatter, because I feel like it doesn't have that rigidity that we had when we were in the other file. Now that's a bad part of designing this item in a vacuum, like I did, but at least we can easily tweak it. Now, we still want a cylinder coming out of this ram, and we want an easy way to bolt this on and change it. So what I'm thinking of initially is sort of a wedge shape, and let's take a look at how that would work. What we would need is another cylinder, so we can just take our ram and duplicate it. So now we have a, let's call it a piston. And we can extend the piston, reduce its diameter, so it's probably going to be something like that. And the piston should be roughly, I think, shorter than the ram. So maybe something like that. And it comes down like that, and then there can be a wedge part where this actually bolts on. So I'm happy with that for the piston for right now. And then we just need to create a cube. It's a very large cube right now. Let's fix that. Make it a nice small cube. And then we can transfer the cube to the position of our spring. Might be a good time to rename the spring. Actually, let's transfer the cube to the position of the piston. There we go. So now we have our cube, and we can move it down here. And of course, this is an example of modeling on a really strange work plane. We're modeling at an angle, and we're just sort of topsy-turvy. So what we can do now is convert that to an editable object and start to fit it. So if we grab this face down here, we can move it down. If we grab this edge, we can maybe change the axis mode to object, and then just wedge it like that. And maybe we can go to the back face right here and squash it down a little bit. Bring these side faces out a little bit so we can just scale them out. And what we sort of have now is a platform that the spring can be bolted to. So we can have a couple of bolts running through this block, going to the other side where the spring is. And then the spring sort of takes on this replaceable look. You know, you might hear someone say, hey, one of the Razorbacks is coming in with a busted left spring. One of the guys can just grab it off the shelf and replace it. So we have our hierarchy. We have the ram, which is the entire unit. And then we have the piston, which is the part that moves inside of the ram. Normally it'll probably be almost fully retracted like that. Then we have our cube, which let's call our bracket. Very generic term for a very generic thing. And then we have our spring. Now we can even have some fun with the spring. We can deform the spring and bend it. Let's play with that really quickly. So this is for animation. If we were to create a bend deformer and transfer it to the position of the spring, scale it down, then we have a deformer that we can essentially bend back and forth like that, maybe with an angle of 90 degrees. So we can 90 degrees, and then we can adjust the strength. What we can do with this bend is align it to the spring, make it a child, and then we can actually bend the spring during animation. That's pretty cool. Probably bend like that. So that's something we can have fun with a little bit later on. But for now, let's see how these springs look. So if we were to rotate the kickstand pivot back into a stored state, we can already see that that works pretty well. The only thing I'd be worried about is that these are now like hooks. Maybe that can be to the Razorback's advantage. It is kind of weird having them hang out there like that, but for now I think we'll allow it. What would happen if we were to turn them in a little bit? Like that. Let's see, that means that when the kickstand pivots down all the way to 0, they're sort of kicked out like that. Not necessarily a bad thing, but not really great either. So yeah, let's just leave those like that for now. I mean, we started off with those spiky pistons, and now we've got these hooks. Who's to say we couldn't change it again? Alright, so I think that's all we're going to cover for this one. You know, we've successfully smoothed out the arms at the top. They look a lot more polished. And now we've created these springs. You know what, man? As I'm looking at those springs, they look really flimsy. I'm just going to fatten them up a little bit. Easiest way to do that is to select the faces on the bottom. And then we can use the normal move tool. And this moves the faces along their normal, basically making the spring fatter. So we start off right there and we can just fatten it up a little bit. Also put like a 30-degree smoothing on this. Let's see. 26 degrees looks to do the trick. Let's leave it at 40. Alright, so now the springs are a little bit more robust. And yeah, as I was saying, so we replaced the medieval spikes with more modern springs that might serve more of a purpose as well, because they're sort of hook-shaped. So I'm not really sure what that could be used for, but maybe it'll come into play. And we have our spare blades, we have our articulating arms, and we have our instrument cluster that is getting a little scarier looking every time we work on it. And the machine is definitely starting to look more like a machine and less like something you take for a ride on the weekends. So I hope you've been enjoying this screencast series, and until next time, see ya.